all carbon fibre starts its life as string. It can be woven into cloth or made straight into a high-stress component. These carbon fibre drive shafts are destined for very expensive road cars and Le Mans race cars. Manufacturers and racers need to know exactly how much stress a carbon fibre drive shaft can take. And this is the world of Chris Jones, a test engineer for a leading manufacturer.
So Chris, test engineer, I'm guessing that means you get to test things to destruction.
Yeah, pretty much.
Because that's where I think you can help me. Because I know carbon fibre is used in Formula One because it's light and because it's strong.
Yeah.
But how light and strong compared to other materials? And that's where you can help.
Well, what we've got here, we've got two prop shafts here.
Right.
I don't know if you want to pick that up. And,
so this is a steel prop shaft?
Yes.
So this big lump of metal connects the engine to the wheels.
That's
so
right,
all the power goes through this.
Along the car, yeah.
Right,
That's
okay.
Right. And here we've got the carbon fibre equivalent to the same thing. So if you want to pick that up and...
doesn't weigh anything at all. But, I mean, obviously, if carbon fibre is as strong, if this is as strong as the steel one, it's a no-brainer because this is so much lighter, you'd use this.
Exactly.
But can you tell me how much so? Can you show me how much, if this is as strong as that?
I think we can do that.
What I'm asking is, can we break them?
Yeah, we can give it a shot anyway.
Okay, right.
This rig uses torque or twisting force to test materials until they break. Sensors can judge exactly how much force it managed to cope with before snapping.
So when this is working at full tilt and at full power, how much torque can go through it?
So 8,000 newton meters we can put through with this rig.
It's really not the kind of device to catch a tie-in, is it?
No, not at all.
To put this in perspective, it requires around 2 Newton meters of torque to drive a corkscrew into a wine cork. This rig can produce 8,000. It's a lot of plonk.
So that piece of plastic and these glasses will protect us from the immense forces being unleashed with it.
That's the plan anyway.
Good. Okay,
so,
fine. Yes. A bit further back, maybe?
Okay, it should be okay there. So, right, okay, well, that's on its way up. You see the numbers are rising here.
293, that's a lot of Newton meters of torque.
It is.
This is twisting.
You can see, if you look at this end here, you can see this end of the machine, it'll be twisting around. It's yielding already, look. There we go.
So what's this showing us?
That's yield there, so the machine is about to fail, so any second now it's about to snap.
Really?
So the machine is just distorting now. You should be able to see it necking.
Necking, yeah, I know what you're thinking, but here it means when a material gets thinner in cross-section. It's an indication it's just about to fail.
Oh yeah, there it goes there, look. Oh, it's gone.
I think we'll stop that there.
That's ruined.
I think it is.
You have broken it. What did it make it to?
That got to 1,376 newton meters.
1,300 Newton meters, and it's now a corkscrew.
It is.
Yeah,
there you go then.
It certainly didn't spring back either.
No.
Did it? That is quite badly spoiled. Well, now we know the limits for that one. Let's see what the carbon fibre equivalent can take.
Okay, shall we get that one in?
And straight away, that's a reminder of how much lighter this thing is.
Lighter, but in theory, much stronger. And much more expensive. £2,500 for this shaft alone.
It certainly looks better, doesn't it?
It does. Quite attractive, aren't they?
I can't believe it's going to have any strength compared with the big steel one.
Okay, shall we see what we can do out of this one?
Right. So 1,376 is the target. If it can match that, it's matched the much heavier steel.
Yes, that's right.
Pile it on.
We're off.
So it's climbing 647, 8. It doesn't hang about this machine, does it? 9, 10, 11. And we're getting close to where the steel went. 13. It's just gone straight past it. And it's completely blitzed.
There's no damage to the shaft there whatsoever.
So this much lighter,
much stronger.
Just gone completely howling past. What will it make it to, do you think?
I'm hoping 4.5.
4.5 compared to 1,300 for the steel, and it weighs so much less. Oh, we're on the way to that. 4, 2, 3, 4, over 5. I was just about to ask what happens when it goes.
That's what happens
Now
when it
I
goes.
know. I didn't jump. I didn't jump. So it made it to
It made it to 4,728 newton meters compared to our
1300.
1300-ish.
And it's so much stronger than the big heavy steel one. And let's not forget, it's just made of this stuff, isn't it? It's just threads. Basically, it's just
expensive reel of string.
expensive string, isn't it?
Pretty
That's
much.
it.